You are approaching Jupiter at nearly 60,000 kilometers per hour. At this speed, Earth would take days to cross beneath you. But Jupiter does not behave like Earth. It grows in your window at an unsettling rate. Bands of orange, white, and deep rust stretch across its surface like scars. At first, it looks calm. Then your instruments begin to spike. Radiation levels are climbing, fast, too fast. Systems begin to glitch, signals distort. And in that moment, one realization cuts through everything. This is not just a planet. This is one of the most extreme environments in the entire solar system. Jupiter has fascinated scientists for centuries, from early observations by Galileo Galilei in 1610 to modern missions led by NASA. Today, data from the Juno spacecraft is giving us the most detailed look ever at this gas giant. And what we are discovering is far more intense than anyone imagined. Let us start with the scale, because without understanding its size, nothing else makes sense. Jupiter's diameter is about 143,000 kilometers. That means more than 11 Earths could fit across it side by side. In terms of volume, it could hold over 1,300 Earths inside. But even more important is its mass. Jupiter contains about 2.5 times the mass of all the other planets combined. Every rocky world, every gas giant, every icy body in our solar system together still do not outweigh Jupiter. Planetary scientist Dr. Scott Bolton, the principal investigator of NASA's Juno mission, has described Jupiter as a planetary system in itself, and that is not an exaggeration. Its gravity dominates everything around it. Now here's where things become even more interesting. During the early formation of the solar system, Jupiter came very close to becoming a star. According to astrophysicists, if it had gathered roughly 80 times more mass, the pressure and temperature in its core would have triggered nuclear fusion. That's the same process that powers the Sun. Instead of a planet, we would have had a second star. Researchers at institutions like NASA and the California Institute of Technology have modeled these early conditions. Their findings suggest that Jupiter played a critical role in shaping the entire solar system. Without it, Earth may not even exist. But Jupiter did not become a star. It remained a gas giant, and that is where the real danger begins. Unlike Earth, Jupiter has no solid surface. What we see as its surface is actually the top of a vast atmosphere. As you descend, the gas becomes denser. Pressure increases rapidly. Temperatures rise. There's no clear boundary where you could land. At the upper levels, wind speeds can reach 400 to 600 kilometers per hour. These are not temporary storms. These are permanent features driven by internal heat and rapid rotation. Jupiter rotates once every 10 hours, which is incredibly fast for a planet of its size. This rapid spin stretches its clouds into long bands and fuels massive jet streams. One of the most famous features is the Great Red Spot. Scientists have been observing it for over 350 years. Some estimates suggest it may be even older. This storm is large enough to swallow Earth completely. Wind speeds inside it exceed 400 kilometers per hour, and it continues to rage without stopping. Dr. Andrew Ingersoll, a planetary scientist at Caltech, has studied Jupiter's atmosphere for decades. He explains that these storms are not just surface-level phenomena. Data from the Juno mission shows that they extend hundreds of kilometers deep into the planet. And that's only the beginning. As you move deeper, pressure increases to extreme levels. At a certain point, hydrogen gas is compressed so intensely that it transforms into liquid metallic hydrogen. This is not something we see naturally on Earth. It behaves like an electrical conductor, similar to metal. This layer is critical because it generates Jupiter's magnetic field. Earth's magnetic field protects us from solar radiation. It deflects charged particles and helps maintain conditions suitable for life. Jupiter's magnetic field, however, is about 20,000 times stronger than Earth's. According to NASA measurements, it's the largest planetary magnetic field in the solar system.
It extends millions of kilometers into space, forming a massive region called the magnetosphere. If you could see it from Earth, it would appear larger than the moon in the night sky. But this magnetic field doesn't just protect, it traps charged particles from the sun and accelerates them to near light speed. These particles form intense radiation belts around the planet. NASA scientists have measured radiation levels near Jupiter that are thousands of times stronger than those around Earth. An unprotected human entering this region would receive a lethal dose in minutes. Even spacecraft struggle to survive. The Juno spacecraft, which entered Jupiter's orbit in 2016, was designed with a special titanium radiation vault weighing about 200 kilograms. This shield protects its sensitive electronics. Despite this, Juno can only make close passes for limited periods before the radiation becomes too dangerous. Earlier missions faced similar challenges. The Galileo spacecraft, which studied Jupiter in the late 1900s and early 2000s, experienced severe radiation damage over time. Its final mission involved sending a probe directly into Jupiter's atmosphere. That probe transmitted data for less than an hour before being destroyed by extreme pressure and heat. Now, let's zoom out and look at Jupiter's influence on the entire solar system. Jupiter's gravity is so strong that it has shaped the orbits of countless objects. Scientists have proposed a theory known as the Grand Tack model. According to this model, Jupiter migrated inward toward the Sun early in its history, possibly reaching as close as the current orbit of Mars before moving back outward. This movement would have scattered material throughout the solar system, preventing planets from forming in certain regions. It may explain why Mars is much smaller than Earth and why the asteroid belt exists.
Astrophysicist Dr. Alessandro Morbidelli, one of the key researchers behind this model, has suggested that Jupiter's migration fundamentally reshaped the architecture of our solar system. Even today, Jupiter continues to influence space around it. Comets and asteroids that pass nearby can be captured, redirected, or ejected entirely. In 1994, scientists witnessed a dramatic example of this when comet Shoemaker-Levy 9 collided with Jupiter. The comet had been torn into multiple fragments by Jupiter's gravity. Each fragment impacted the planet at speeds of about 60 kilometers per second. The resulting explosions released energy equivalent to millions of nuclear bombs. The impact scars were visible from Earth and larger than our entire planet. Events like this show how Jupiter can act as both a shield and a threat. Some scientists believe it protects Earth by capturing dangerous objects. Others argue that it can also send objects toward the inner solar system. The reality is complex, and research is ongoing. Now, let us turn to Jupiter's moons. Jupiter has over 90 known moons, and some of them are among the most interesting objects in the solar system. Io, the closest large moon, is the most volcanically active world we know. Its surface is constantly reshaped by eruptions. This activity is caused by tidal forces. Jupiter's gravity pulls on Io, stretching it and compressing it, generating heat inside. Europa, another moon, has a thick icy crust with a vast ocean beneath it. Scientists believe this ocean may contain more water than all of Earth's oceans combined. This makes Europa a prime candidate in the search for extraterrestrial life. However, Europa orbits within Jupiter's radiation belts. The surface is constantly bombarded with high-energy particles. Any future mission will need to deal with this extreme environment. Ganymede, the largest moon in the solar system, even has its own magnetic field, but it still cannot fully escape Jupiter's influence. These moons are scientifically valuable, but they are far from safe. Let us pause for a moment and bring all of this together. Jupiter is not just dangerous in one way, it is dangerous in multiple ways at the same time. Its atmosphere is violent, its pressure is crushing, its radiation is lethal.
Its gravity is overwhelming. Every layer presents a new challenge. And yet, scientists continue to study it. Why? Because Jupiter is a key to understanding not just our solar system, but planets across the universe. Gas giants are common around other stars. By studying Jupiter, we learn how these massive worlds form and evolve. The Juno mission has already revealed surprising discoveries. Instead of having a solid core, Jupiter appears to have a diffuse, fuzzy interior. Its storms extend much deeper than expected. Its auroras, the glowing lights near its poles, are powered by interactions with its moons and magnetic field. These findings are changing our understanding of planetary science. But despite all of this progress, one fact remains. Jupiter is not a place humans can ever explore directly. There is no surface to stand on. The radiation environment is too intense. The pressure and temperature are too extreme. It represents a boundary, a place we can observe, study, and learn from, but never truly visit. And that's what makes it so fascinating. It reminds us that the universe is not designed for human comfort. It is vast, powerful, and often hostile. Jupiter is one of the clearest examples of that reality. So the next time you see Jupiter shining in the night sky, remember what you are really looking at. A world larger than anything we can truly imagine. A system that shapes everything around it. A place where storms never end, radiation never stops, and forces beyond our everyday experience are constantly at work. If you found this as fascinating as scientists do, make sure to stay connected for more deep space explorations. Because out there, beyond Jupiter, the universe only gets stranger.